Hello, my name is Alex O'Hare. Welcome to my channel. This video is the first of potentially a series of videos on my attempts to improve the efficiency of a coilgun. So this first video will just serve as an introduction to give you my ideas for the project, a bit about myself, why you should watch the video, and to gauge if there's any interest. So if you like the video, please do feel free to leave a comment or a like and subscribe and so on. As you can probably tell, I'm new to YouTube, so in the next video I will try and resolve some of the many problems, such as the echo, which I can't appear to get rid of at the moment. So first of all, I'd like to give a big shout out to Levi Johnson, who essentially inspired this project. So for anyone that's tried to make a coil gun, and has done their research, they've probably come across Levi Johnson, because there are really not that many papers on coil guns in the literature. I guess because it's the frontier of research is military secret, right? And apart from that, you only really see people making these recreationally for fun, like without any specific purpose in mind. But one of the only people I've seen in YouTube actually trying to solve the problem, which plagues coil guns, which is that they have incredibly low efficiency, is Levi Johnson. And unfortunately he did not make a coil gun in the end, but that's kind of a testament to his principles, right? He thought, if I can't make an efficient coil gun, then I won't do it. He stopped the project in the end because of, I think, stating lack of materials, so he needed an oscilloscope to do proper analysis and so on. So he left it at his final design stage, which was a barrel module. He said he would have redone the design completely, I think. But anyway, this is a great series of videos to watch to get some background on coil guns. In the next video, I will try and give an introduction to some of the mathematics and physics behind them. As I said, this primary video is just a very, very brief introduction to the project. So, for those of you that have no idea what a coil gun is, so it can be very briefly summarized as follows. So, if you wrap copper wire in a coil like this, doesn't need to have a core. It helps if you have a conductive core, you don't need to. Then you will generate a magnetic field within the coil. So the magnetic field will be concentrated within the center. So if we just look here, then you can see exactly what I mean. Okay. Yeah. So you have the magnetic field essentially centers around the center of the coil. Okay, so the problem with this is then, well, first of all, so when you pass a ferrous object through the inductor, it will be attracted to the magnetic field, of course. But the problem that we have, if we want to use such a system as a weapon, is that when you put the ferrous object in through the coil, it gets attracted to the center, and may go out slowly, but generally will, if it's just a single coil like this, will just get stuck in the middle there. And so the attempt to solve this problem, which most people use, is having some kind of sensor which tells you when the projectile has reached the center of the inductor, and then switching off the current to effectively disable the magnetic field allowing the projectile to carry on going. And then sometimes people have several coils, so the projectile goes through a series of inductors being continuously accelerated before being fired out of the barrel. Okay, so this is one of the main problems, right? Is that you get the projectile stuck in the center. And the issue is that, as sophisticated as modern electronics are, it's the sensors are still too slow. And the time in which the magnetic field takes to dissipate is also too slow. So you still get some pullback from the magnetic field, even though the projectile will carry on going. This means that it leads to very low efficiency. So on the hobby scale, I believe people generally achieve around 3 to 5% efficiency at best, and then in research grade, to our knowledge at least, in research grade weapons, they can achieve up to something around 15%. So my goals for this project are to research the problem and to try and find a way in which we can improve the efficiency of a coil gun, and my aim will be to produce a coil gun which achieves efficiency of around 20%. So a bit about me, so that you know I'm not just any old guy. Well, it doesn't matter if I was any old guy. What I mean is that, just so you know, my background, so I'm a doctoral student in computational neuroscience, so it's a very interdisciplinary subject. So whilst I do have a bit of a physics background, so I did a master's in biophysics. I'm a mathematician, which helps a lot. But yeah, essentially I'm not an electronics engineer. I'm no kind of engineer at all. This is, so, a lot of this, if you decide to watch this series, you'll be learning with me. Okay, so just giving you a kind of disclosure there of my lack of knowledge and the fact that I will be learning in this process. Like I'm not an expert. If you want a thorough introduction to coil guns, I would suggest the videos, for example, by Levi Jansen, or to the general principles of electronics. You can check out Electroboom, who is great, or you can just go and read the textbook. Okay, so a bit about coil guns. Why would we want to make an efficient coil gun? What's the point? Why is this better than just a normal gunpowder-based firearm? Well, there are a few advantages. First of all, with a coil gun, you eliminate the need for gunpowder because your method of expelling the projectile from the gun is through electricity, essentially electricity and magnetism. So you don't need a chemical-based propellant. So what this means is that, in practical terms, if you're in the military and you have to store lots of ammunition, you don't have the risk. You don't have this risk of it being a liability in terms of of your enemy trying to explode it, right? Because you just need steel pellets, steel bullets, without any gunpowder, or steel or iron, any ferrous material. Iron is generally the best, I think. So that's one advantage. Another advantage is that they are generally a lot simpler. And what do I mean by this? That if you have a well-designed coil gun, you can literally give it to anybody and just tell them to press the trigger. The same could be said for gunpowder firearms and perhaps I'm making a bit of a straw man there, but yeah, I don't know. I just think it's a lot. There's really nothing to it, and whilst they do have some faults, there's really not that much that can go wrong. Yeah, I'm going to backtrack on that. Let's just go with the lack of gunpowder for one advantage. And why else would we try to make the coilgun efficient? Because it's fun. It's fun to do science, right? So specifically for this project, I will be focusing on efficiency, as I said. I will not be making a super powerful coilgun, firstly because that would be illegal where I am. So I'll be making the coilgun within the legal limits of projectile velocity and so on. So as you can see here, this is my initial design for the casing of the coilgun, which is really irrelevant because without the science behind it, it's useless, right? So, but anyway, this is designed based on the amount of power I estimate I will need, and with safety in mind. So I'd rather not just build a PCB with a bunch of supercapacitors without any insulation. Because again, I'm relatively new to electronics, that would be dangerous. So I think this is at least somewhat safer, so I will be 3D printing this casing and then setting everything up within the casing of the gun itself directly. Yeah. So I can run you through this a little bit. So in the back here we have 4 separate capacitor banks, each holding 3 capacitors. I'm planning to use 50 volt, 10,000 microfarad capacitors, 12 of them. They will not all be used at the same time. Essentially, can't remember what I got to. I think I'll use around 4 at a time, and then they will cycle. So while one is charging, the other is while one set is charging, the other is discharging, and so on. So I got some spacing in between the capacitor banks for the cables to go. We've designed this kind of piping here so that there are relatively few sharp bends in the cable. As far as I know, having kind of sharp angles in your wiring can cause arcing, which I'll also discuss in the next video. So it's just a safety requirement, really. Obviously, if this was a military-grade weapon, we would have something quite a bit more robust than that, but I think it should serve the purposes of the prototype. Then in the center here is where we're going to have the electronics and circuitry. We've got this little ergonomic trigger here. So yeah, the trigger is very simple as well. So it's essentially just an electronic switch, so that if you're going to make your own crossbow or conventional firearm, the tricky bit really is designing the trigger. So this simplifies a lot of the work. We still need a way to load the projectile, of course. So I've got here a kind of bolt action mechanism. So I'll have a spring in the back here. The bolts will go in here. You pull the bolt back. The bullet pops up. You push the bolt forward. You push it into the barrel, and then you hold the bolt in place with the catch there, and then pull it back again when you need to fire the next shot. Okay, and then your magazine will go in the bottom there. And so on the side here, I've got a space here for a potentiometer, so we can perhaps change the power of the shot. A switch for each capacitor, so ABC indicates the capacitor bank, and then 1, 2, 3, 4 indicates which Oh, sorry, 1, 2, 3, 4 indicates the capacitor bank, and then ABC indicates which capacitor it is. So you can turn one and off if you think one of them's gone bad or whatever. And then here you have a space for an on-off switch and a light. And then on the side here, I've got a space for an LCD screen, which can hopefully be programmed to give us a readout of which capacitors are charged, to what extent, and so on. Perhaps even the projectile velocity. And then finally on the end here, I've got a space for a laser pointer, just for fun. So as I said, the design of the accelerator itself is not done yet, so the coils will go around this pipe here, and then we'll have the electronics in the back there. So yeah, I hope you like my design. This is based off this weapon from Fallout 4, which is quite cool. It's a synth rifle. I just thought I'd go for a kind of modern design, given that it's or will be a modern weapon. Okay. Having said that, it is actually the only sort of square boxy rifle I've come across is the HKG-11 made by Heckler & Koch back in the 70s and 80s, I think, which actually never went into production. But you can see it's not dissimilar. So yeah, I think that's it. Oh yeah, just to say that, okay, so in terms of commercially available coil guns, the only people, as far as I know, that have made them are Arc Flash Labs. I think they have, well, you can find several videos of them on YouTube. Yeah, it says here, 75 for the pound semi-automatic ghost rifle. I will do my research. I don't want to make any claims, but I'm pretty certain that they didn't manage to improve the efficiency drastically. Let's see if it says anything here, but yeah, it's a very nice product. Efficiency, 2.8%. So the only coil gun which is commercially available, to my knowledge, has an efficiency of 2.8%, and it weighs what? Something like 9 kilos, isn't it? Let's see. Does not say. I can't see it there. Yeah, and then apart from this, there was a recent story in the news that the Chinese military have made a coil gun which has a higher firing rate than conventional assault rifles for use in crowd control. I guess we will never know the specs of that weapon, but doesn't stop us from having some fun with this. So I've been rambling on a lot. As I said, I hope you like the design. If you would like to see more videos, please drop a comment, or give a like, or whatever, and you can let me know specifically what you'd like to see as well, if you want. If you have any suggestions to change the design, and yeah, I mean, again, given my background, I will try to give a fairly high detail technical approach to this subject, so to explain the mathematics and so on behind it. But yeah, the next video will come in a few months, mainly because this is I do this in my free time. I'm working full time in neuroscience, so yeah, and also to give you guys enough time to gauge if you liked it. And next time I'll also prepare a script instead of rambling constantly. Okay, thanks very much.